This is a video walkthrough for the Unit 4 review. In 1 through 4, we're asked to use the given information to draw an angle in standard position and its reference triangle. Then we're going to use the reference triangle to find the trig ratio. So in 1, if cosine of theta is 2/3 and theta is an angle between 0 and 90, then we can draw a triangle with an adjacent side 2 and a hypotenuse of 3. And now we can use the Pythagorean theorem. 9 minus 4 is 5, so our opposite side must be the square root of 5. And there's our angle theta. And we're asked to find the value of cotangent, which remember is the reciprocal function for tangent. So tangent of theta is equal to opposite over adjacent. And so that means that cotangent is the reciprocal to that, which is 2 over root 5. And in rationalized form, that's 2 root 5 over 5. In number 2, we're given that sine of theta is 7/25, and theta is an angle between 90 and 180. So if sine is 7/25, then if we draw an angle theta in standard position in its reference triangle, opposite side is 7, hypotenuse is 25. That's going to make our adjacent side -24, Pythagorean triple. And so we are asked for the value of secant. Remember, secant is the reciprocal of cosine, so I'm going to find the cosine value first. And cosine is adjacent over hypotenuse, -24/25. So secant of theta is the reciprocal to that, -25/24. Moving on to number 3, tangent of theta is 3. Remember, as a fraction, 3 is 3 over 1. And theta is an angle between 180 and 270. So I'm going to draw a picture of an angle in standard position that lies between 180 and 270. And if tangent of theta is 3 over 1, that means our opposite side is -3, adjacent is -1, because remember they both have to be negative in quadrant 3. We can do the Pythagorean theorem to figure out what the hypotenuse is. It's square root of 10. And so we're asked for the value of secant of theta. Now secant is the reciprocal to cosine, so cosine is adjacent over hypotenuse. I'm not going to rationalize that because to find secant, I'm just going to take its reciprocal. And so secant of theta is -square root of 10. Last one in this section, sine of theta is -3/5, and theta is an angle between 270 and 360. So we're going to draw an angle between 270 and 360, and its associated reference triangle. Sine is opposite over hypotenuse. That's going to give us an adjacent side of 4, Pythagorean triple. And we are asked for the value of secant of theta. Secant of theta is the reciprocal to cosine, so cosine of theta is adjacent over hypotenuse. That's going to make secant theta the reciprocal to that, which is 5/4. And we're done with this section. For 5 through 10, we're evaluating each trigonometric function, and these are our reciprocal functions. So secant of 30, I'm going to draw a picture of a 30-degree angle, so that would be quadrant 1. And in a 30-degree reference triangle, we have the opposite side 1, adjacent, square root of 3, and the hypotenuse is 2. And remember, secant is the reciprocal to cosine. Cosine of 30 degrees from our picture is the adjacent side over the hypotenuse side. So that's going to be the square root of 3 over 2. And so to find secant, I'll take the reciprocal of that, which is 2 over the square root of 3, and then just rationalize that. So that's 2 times the square root of 3 over 3. For number 6, we have the cosecant of 135. So I'm going to draw a 135-degree angle. That's a quadrant 2 angle with a reference of 45. So that's going to give us opposite side 1, adjacent -1, and hypotenuse square root of 2. And so cosecant is the reciprocal to sine. So from my picture, sine of 135 is the opposite side over the hypotenuse. I'll take the reciprocal of it to find the value of cosecant of 135. So cosecant of 135 is the square root of 2. Now number 7, finding the cotangent of 120. I'll draw a picture of a 120 degree angle. That's a quadrant 2 angle with a reference of 60. So that's going to give us an adjacent side -1, opposite square root of 3, and hypotenuse 2. And cotangent is the reciprocal to tangent. Tangent of 120 degrees is the square root of 3 over -1. So cotangent of 120 is going to be the reciprocal of that, which would be -1 over the square root of 3, or rationalized negative square root of 3 over 3. For number 8, we have the secant of 90 degrees. 90 degrees is a quadrantal angle. Remember that Andrew sells trash cans can help us find the values for quadrantal angles. Secant is the reciprocal to cosine. So we're going to relate this to cosine of 90 degrees. And remember, 90 degrees is a terminal side that is vertical when drawn in standard position. What I've just highlighted is that on the right side of our coordinate axes, the cosine values will be positive. On the left side, they'll be negative. 90 degrees is right in between those, so cosine of 90 must be equal to 0. 0 has no reciprocal, so secant of 90 degrees is undefined. And last two, cosecant of 210 degrees. 210 degrees is a quadrant 3 angle. So if we go 210 degrees, that gives us a 30-degree reference in quadrant 3. And so our opposite is -1, adjacent is negative square root of 3, and hypotenuse is 2. And cosecant is the reciprocal to sine. So sine of 210 degrees is opposite over hypotenuse, -1/2. Cosecant is the reciprocal to that, so that's just -2. And last one, cotangent of 90. Cotangent of 90 is the reciprocal to tangent. Well, if we remember that tangent of 90 is undefined, remember that from your parent functions, then cotangent of 90 must be 0, because remember 0 is the number that has no reciprocal. For 11 through 16, we're going to write each as a single trigonometric expression and then evaluate. So in number 11, it looks like we have a cosine A, cosine B, minus the sine of A, sine of B, sort of a pattern. And so that's going to equal the cosine of A plus B. So this simplifies to cosine of 105 plus 15 is the cosine of 120 degrees, and the cosine of 120 degrees is -1/2. In number 12, it looks like we have a 2 tangent theta over 1 minus tangent squared of theta, sort of a pattern. And remember, that's equal to the tangent of 2 times theta. And so this expression is equal to tangent of 2 times 15. So that's the tangent of 30 degrees, and the tangent of 30 degrees is equal to the square root of 3 over 3. In number 13, we have 2 times the sine of 165 times the cosine of 165. That looks like a 2 sine of theta times the cosine of theta, which remember is equal to the sine of 2 theta. That's on your reference. You don't have to remember that one. And so this is going to equal the sine of 2 times 165 degrees, or the sine of 330 degrees, and the sine of 330 degrees is -1/2. For number 14, it looks like we have a sine of A, cosine of B, minus sine of Looks like we have a typo on number 14. I'm going to change this because it really would be 0 if we did that subtraction of two things that are the same. So let's change this one. It should be sine of 285 times the cosine of 15 minus the cosine of 285 times the sine of 15. Now it's not 0 anymore. And that's a sine A cosine B minus cosine A sine B, which is equal to the sine of A minus B. And that's the sine of 270 degrees, which is -1. And in number 15, it looks like we have a 1 minus 2 sine squared of theta, which is equal to the cosine of 2 theta. Remember, there are 3 different identities for cosine of 2 theta. This is one of them. So this is going to be equal to the cosine of 2 times 75, which is the cosine of 150 degrees, and that's going to be negative square root of 3 over 2. Last one, tangent 140 minus tangent 20 over 1 plus tangent 140 tangent 20. That's going to be a tangent A minus B. So that's tangent 140 minus 20. And that's going to be the tangent of 120 degrees. And the tangent of 120 degrees is negative square root of 3.